Hello, welcome to dear teacher Ravi Tuitions. Ravi Tuitions give you coaching online and also offline. Online at present I am teaching lessons on YouTube. Every day morning 6 o'clock I am teaching class 10 maths, and at 4 o'clock evening I am thinking of starting teaching 9th class. Okay, so today onwards I am going to start teaching geometry of class 9 CBSE maths. So then after teaching 2-3 months, definitely I am going to start from January 10th class, January or February, whatever, I am going to start 10th class, right. So now most of the students are having a difficulty in geometry. Now because it is the second term, we are in the December month, so most of the schools must be doing quadrilaterals, right. So I have to, and also this quadrilateral is an important chapter and it gives you foundation. So now quadrilaterals, you should be aware of all the basics. What is a quadrilateral? What are the different types of quadrilaterals? Okay. So what is a quadrilateral? Very simple. It is a four-sided figure. A four-sided figure, four-sided polygon. Polygon means closed. Okay. A closed four-sided figure. You can have, say this is a quadrilateral, four side. So now different types, there are some types of quadrilaterals like parallelogram, rectangle, square, rhombus, kite, trapezium, etc. Okay. So now I am not going to focus on the smaller things. Directly I am going to start the theorems. So to know the theorems, to do the theorems, we have to recall congruency properties, congruency rules. Almost in all the theorems we are going to apply congruency rules. So everybody should be aware of congruency rules. So there are first one is SAS congruency rule, SSS congruency rule, ASA congruency rule, and RHS congruency rule. Fifth one, corollary, actually AAS. Okay. AAS also you can use to prove two triangles congruent. Whenever we wanted to prove two triangles congruent, so these are the rules you have to take. So I am not going in detail. SAS, side angle side. SSS, three sides of one triangle are equal to three sides of another triangle, then both the triangles are congruent. ASA, angle side angle property. Okay, and side is included between two angles. First one, angle is included between the two sides, and the last one, two right angle triangles. If hypotenuse and the side of both the triangles are equal, then both right triangles are congruent by RHS. Okay. Now let us go directly with the first theorem. First theorem, I have ncert textbook. I will take the theorems from this book. Okay. So it is the latest publication, because latest publication will have latest syllabus. Okay. Some students are having old syllabus, old books. Old books will be having old syllabus. So I am using the new syllabus book. Okay. So the first theorem, 8.1 theorem. So every theorem there will be one statement. Depending on the statement, we should draw a figure, and after drawing a figure you should write the figure details in the given, and then you have to indicate what we have to prove in RTP section required to prove, and if there is a construction you have to go for construction and then prove. These are the steps you have to follow. Let me write a statement first. In a the diagonal of a parallelogram, a diagonal of a parallelogram divides it into two triangles of equal area. This is the statement. A diagonal of a parallelogram divides it into two triangles of equal area, two congruent triangles. Okay, two triangles. I'm sorry, I should write congruent triangles. So in the place of two congruent triangles. This is the statement. So what we need to prove this? We need the definition of the parallelogram. What is parallelogram? You should be aware. Let us take a parallelogram. This is a parallelogram. Parallelogram, by this time you should know what is a parallelogram. Parallelogram means opposite sides are parallel. These two are one pair of opposite sides. If you name it A, B, C and D, AB and CD are opposite sides, they are parallel, and BC and AD are also opposite sides, they are also parallel. Only this information we are aware. Okay? Using this information, we should prove the theorem. Okay? What we have to prove? We have to prove that the diagonal divides it into two triangles, two congruent triangles. So for this, you need to draw a line, join the diagonal, diagonal is joined. So now let us express everything, whatever we have drawn, you should indicate it in the given. ABCD is a parallelogram. If you write like this, okay, GM, then we call it as a parallelogram. It is a short notation to draw a parallelogram. Hello, this is 9th class maths. I don't know why we take parallelogram. So I don't know whether you are asking about the theorem or not. So now let us rub this. So ABC is a parallelogram and AC is a diagonal. AC is a diagonal. This is just we know. That means parallelogram properties we can make use of in this proof. So now what is required to prove? RTP, because AC is dividing the whole parallelogram into two triangles. So they are congruent. We should prove them. They are congruent. ABC is congruent to ADC. This is what we wanted to prove. Okay. So you can take even BD. BD भी ले सकते हैं, AC भी ले सकते हैं, BD भी ले सकते हैं. You can take any one diagonal. So if you take one diagonal, it will get divided into two parts, and each part is a triangle. and we have to prove that this triangle is congruent to this triangle, right? Okay. So then let us prove. Whenever you wanted to prove two triangles, you should list out, you should use the properties which will match in this SAS, ASA, okay, and SSS, RHS. So which of these properties will go in these two triangles? Let us check in triangles ABC and triangle ADC. So let us, because three parts are there, let us list out the three. So now we don't know anything, only AC is common, that only is there. We don't know whether AB is equal to CD or we don't know whether BC is equal to AD. We know that these two are parallel lines. Let us say if one is 2, so this is 3 and 4. Okay. So angle 1 is equal to angle 3 because alternate interior angles, and AB is parallel to CD. Because of this we have taken 1 is equal to 3. Okay. So then AC is equal to AC, common, and at the same angle 4 is equal to angle 2, same reason, this is we can write common, and this is alternate interior angles, and BC is parallel to AD. BC is parallel to AD. So therefore, say one side and both sides angles are there, side is included between the angles. Therefore, angle ABC is congruent to triangle ADC by ASA congruency rule. So this is what we wanted to prove, proved. Okay. So now let us go to the second theorem. Okay, I am teaching parallelogram theorems, quadrilateral theorems. So first theorem is over, and let us go to second theorem. Okay. (8.2) statement. In a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. So this is the first property of parallelogram. So in this also we are aware only parallelogram. We know only parallelogram. Okay, let us take the parallelogram. Okay. So let us name it A, B, C and D. It is a parallelogram given A, B, C, D is equal to a parallelogram. That's it. RTP, opposite sides are equal. That means opposite sides are AB and CD. So AB is equal to CD and BC is equal to AD. This is what we have to prove. So we know only opposite sides are parallel. That's it. We don't know anything. So we have to prove opposite sides are equal. So for this, let us take a construction. Construction means you have to join the diagonal. Join the diagonal. So this is construction. Join AC. Now let us go to proof. So prove these two triangles congruent, and from that you will get corresponding parts are equal. So already we have learned how to prove these two triangles congruent. So accordingly you prove it and get it. So for that, in triangles ABC and triangles ADC, list out the three properties. List out the three properties. What are equal? Same way, say this is angle 1 and angle 2 are equal, alternate and interior angles. Angle 3 and angle 4 are equal. So now angle 1 is equal to angle 2, alternate interior angles, and AB is parallel to CD. So now AC is equal to AC. In the same way, angle 3 is equal to angle 4. This is common, and this is alternate interior angles, and BC is parallel to AD. So therefore triangle ABC is congruent to triangle ADC by ASA congruency rule. So we proved, and then corresponding parts of congruent triangles are equal. So by CPCT, C, P, C and T, corresponding parts of congruent triangles, corresponding parts of congruent triangles are equal. So now corresponding AB is corresponding to CD, therefore AB is equal to CD, and BC is corresponding to AD, and BC is equal to AD. So prove. This is what we have to prove. And how do you know that these are corresponding? Okay, you just see these things, you see these two things, opposite to 1, opposite to angle 2, opposite to angle 1 in ABC, opposite to angle 1 in ABC is BC, opposite to angle 2 in ADC is AD, therefore BC, AD are corresponding. Same way 3 and 4, opposite side to angle 3 is AB, and opposite side to angle 4 is CD. So they are corresponding. So this is what we have to prove. This proof is a 2 marks question. Okay. So this is a second theorem. Let us go to one more theorem. Okay, 8.3 theorem. Each pair of opposite sides are equal, then it is a parallelogram. So that means converse of this theorem. 8.3 theorem, theorem number 8.3. Statement: if each pair of opposite sides of a quadrilateral are equal, then it is a parallelogram. It is the converse of 8.2, converse of 8.2. In this, it is given only quadrilateral and opposite sides are equal. So now let us draw a figure, as we have to prove as a parallelogram. Let us take a parallelogram only, but we don't know whether it is a parallelogram or not. So A, B, C and D is a quadrilateral. Is a quadrilateral. We don't know whether it is parallelogram or not. It is a quadrilateral. We have to prove that this is a quadrilateral. So what else is given? Opposite sides are equal. That means AB is equal to CD and BC is equal to AD. So these two things are equal. So using this information, you have to prove ABCD is a parallelogram. So our ultimate target is to prove ABCD as a parallelogram. Okay. So when a quadrilateral becomes a parallelogram, if opposite sides are parallel. If both pairs of opposite sides are parallel, then quadrilateral becomes a parallelogram. So now our ultimate target is we have to prove both pairs of this are parallel. So for that, let us take a construction. In this also join AC, that means make a diagonal. So construction. So construction join AC. So now prove that these two triangles are congruent like previous theorem, and from that take the corresponding parts, and then from that you prove that AB is parallel to CD and BC is parallel to AD. So now let us take these two triangles and see these two sides are equal. So in triangle ABC and triangle ADC, you list out the equal parts. So AB is equal to CD, this is given. So given, and AC is equal to AC, this is common, and BC is equal to AD, this is also given. So all the three sides of one triangle are equal to three sides of another triangle. Therefore, triangle ABC is congruent to triangle ADC by SSS congruency rule. So both triangles are congruent. Now you take the corresponding parts. So CPCT, corresponding parts. So now you take corresponding angles to the first one. ABCD are equal. So what are the corresponding angle? For angle for AB side, this is the angle. For CD side, okay, this is the angle. So angle 1 is equal to angle 2. Corresponding parts of congruent triangles. Now for AC you leave it. For BC, AD are equal. BC opposite angle is let us say 3, okay, and BC is equal to AD. AD is here, so opposite angle is this one, let us say 4. So angle 3 is equal to angle 4. These are the CPCT, corresponding parts of these two congruent triangles. So as 1 is equal to 2, BC will become parallel to AD. As 3 is equal to 4, AB becomes parallel to CD. Okay? So that implies, let us say this is 1 and this is 2. So from 1 and 2, ABCD is a parallelogram. Because one pair of opposite sides are parallel, in 2 one more pair of parallel sides are one more pair of opposite sides are parallel. So both pairs of opposite sides are parallel by 1 and 2, therefore ABCD is a parallelogram. So I will stop at this point because I will take only half an hour. So let us meet tomorrow at the same time, 4 o'clock. Bye bye. If you are not a subscriber, please subscribe, and tomorrow at 4 o'clock. If you are a 10th class students, morning 6 o'clock, 10th class. I am teaching geometrical problems, and if you are a 10th class students, you can attend directly on the same channel, morning 6 o'clock. Thank you. Have a nice evening. हाँ